Hey guys, how are you guys?
Good.
Okay. What have you started, Ashrita, at your school?
We did special factoring, and today we learned changes in tandem.
That was easy, right?
Yeah.
Same thing that we are covering, right?
Yes.
No, I just want to be sure before we move on as well. Okay, Annam, how about you? What are they doing in school?
Um, we just uh we went over like characteristics of some of the functions. So we learned like a piecewise function,
Okay.
and we learned about concave up, concave down. Um we did one other thing. It was like, let me check my notebook because I wrote everything down.
Okay. Ayan, do you have any questions? You're here in this Zoom. Ayan? Ayan? Okay. 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 Akshara has now school. Harshika, what are you doing in school now?
So we started school last week and we didn't do a lot, but we talked about like concave up, concave down, and then we had like a table with like X and Y values, and then we had to find the slope of the line. And we also learned about absolute minimum, absolute maximum, and then like we drew a couple of graphs with the like criterias, and then we also learned point of inflection, and I had my first quiz today, but it was really easy because it was just like the basic stuff. It wasn't like a lot of math. It was just like looking at it and then writing stuff about it.
And we also like learned the even or odd, like so substituting negative x in the function.
Oh, I see. I see. So you're working with more of algebra too, right?
Yeah, right now, yes.
Good to know. One second, guys. There are people who are missing. One second, guys. One second, guys. There are some parents who are not finding the Zoom details. I don't know what is going on. Okay, let's move on, guys. Sorry. There are some people coming in. Okay, let's go ahead. Okay. We'll continue our discussion. We covered limits last week, right? Annam, did you go over the homework for limits?
Uh, I went over it like I saw it, but um I'll complete it this week.
Hey, Shreya, did you go over the old ones?
Not yet.
Not yet. Okay, okay. I know, I know. It's you're just jammed, right? I understand. It's okay. Okay. Navneet, did you have any questions on the homework? Mahir, did you get to the homework?
I did a part of it.
Yeah. Were you able to follow? Harshika, did you have any questions?
I think my mom told you, but I'm taking the SAT in like 2 days, so I haven't had a chance to look at the homework yet.
This is something different.
Okay, man, no problem. Harshika, you can do it later.
Priya, this is Priyanka here.
Priyanka, this is my class, Priyanka. You are logged into the wrong room, and this it's completely distracting this class as well. I am in class. The problem is you are logged into the wrong Zoom. Zoom details I've sent to you with the code that should work, ma.
The code is not working. That's the problem. That's what I'm saying.
For the others, it is working, right?
I have no clue what happened, but
Okay, you want to check, ma?
on the email it is saying what
MA Rangers.
MA Rangers is the same code, right?
Yeah, I've put that
M
code in.
Rangers. I forwarded to you M Rangers.
What?
M Rangers. That's what I see. M Rangers. Last week you logged into the class, right?
Yeah. Just click on the touch. M Rangers.
I will see where is the problem later, but I want to continue my class, ma.
You can disconnect.
Yeah, and please look at the WhatsApp message as well, because that's the login. You are logged in. You did not complain on anything, but I'm not sure. Okay. So if there's a problem, we can rectify later, provided you are able to log in now. Are you able to? I just want to get going with my class. Okay, guys, let's move on. Okay, guys, for today, we are going to discuss rational functions, right? Meaning, we discussed unit 1, okay? We are unit 1, part A we did, okay? In part B, we'll discuss rational and polynomial functions. Rational and polynomial functions we'll discuss. Any questions? So, we are going to get going first with rational functions. We will discuss vertical asymptotes. This will be more of a review. But then, since we are bringing limits into picture, right, we will lay the foundation on what you learnt in Algebra 2. Now that we have already learnt limits, right, this unit is going to be very, very easy. Okay, so it will discuss vertical asymptotes, horizontal asymptotes, okay, or end behavior, okay. Then what else it will discuss? Horizontal asymptote, vertical asymptote, zeros of the function. So these three are the main ones that we are going to discuss. But again, since the limits is the only extra part from Algebra 2, right? It is going to be very easy provided you remember what you have already learned and limits you have followed through the last 3 classes. Make sense, guys? This will just run through. Okay, let's go ahead. So we'll start from, we did till 1.6, right? So we'll be doing 1.7 AB. Okay, now what is a rational function? Anybody? What difference? When we can call it a rational function? When we can call it a rational function? Anybody? We have learned it in Algebra 2, right? So anybody, guys, you can open, or I'll go ahead and tell the definition. Okay, I'll go ahead and tell the definition if you all keep quiet. Okay, so here in a rational function means the numerator is a polynomial, the denominator is a polynomial. Here f of x can't be 0. This is a polynomial. This is also a polynomial. Any questions? Any questions? Okay. Now, okay, now Let's go ahead and try a problem here. Okay. How about we will work only on the domain of rational functions in 1.7. Okay. How for finding a domain of a rational function, right? We'll always do this. Okay. If a square root is present in any function, first of all, if a square root is present in any function, we will say whatever is present is greater than or equal to 0 because you cannot find the square root of a negative thing inside, right? Number one. Number two, the denominator. Suppose you have 1 by something big. The denominator should not be equal to 0. Why? Because division by 0 in mathematics is undefined. Those are the only rules that you have. Now that we are discussing rational functions, the only thing that will hold good is this, meaning you will have a denominator, numerator. Okay, the denominator will not be equal to 0 is the only thing you need to see. Whatever makes your denominator 0, there you have a problem, meaning the domain will break there. In the sense, I'll show you an example. Okay, so the domain really is defined by wherever you're making the denominator equal to 0, that will put down some breaks in the domain of the rational function. Let's go ahead and try one. We have already done this. Okay, x square minus 4 divided by 3x plus 12. X square minus 4 by 3x plus 12. So as soon as you see this is a rational function, numerator is a polynomial, denominator is a polynomial. So to find out the domain of the rational function, you'll just equate this. It's not equal to 0, right? That being the case, what would happen? 3 times x plus 4 is not equal to 0. X is not equal to minus 4. Any questions? Now, how will the domain break? So x is not equal to minus 4 means on a number line, minus 4, there is a problem. Okay, it's not equal to minus 4. Okay, so intervals will be split as minus infinity to minus 4, then minus 4 to infinity. Any questions? So the domain can be written as minus infinity to minus 4. Is minus 4 included? No. So there is a parenthesis. Why it's not included? Because it cannot be equal to minus 4. Union, then what? Again, minus 4 is not included, but to infinity. Infinity, you'll never have square brackets, so you should use parenthesis. Any questions? You know this from algebra 2, but very likely many of you would have forgotten, so we are revising it now. Okay, now let's go ahead and try this. How about this? 4x, let me give you this. 4x minus 1, you know what? Answer. Let me move it. Okay. How about the okay, how about this? Let's go ahead and try this one. 4x minus, what did I say? Okay, 4x, are you able to see, guys? I just want to make sure you're able to see what I'm writing on the board. You're able to see? Okay, so 4x minus 1 divided by x square minus 2x minus 24. That would be, you're going to find the domain of this rational function. The only constraint is denominator is not equal to 0. Pretty simple. But when you write the domain, you need to be careful with the brackets that you use wherever it is. That's the only thing you need to be careful. This will run because we dealt with limits as a separate piece as well. Okay. Shreya, you have to equate the denominator to 0. Equate. See, when the denominator is equal to 0, then division by 0 is not possible. The function will not exist. So what you need to do is minus 2x minus 24 is not equal to 0. You know how to factorize this, Shreya? Go ahead. You will cope up. It's like getting into the ocean now, right? Without algebra 2. That's right, Ashrita. I think you can proceed with the next one. Yep, that's right. That's right, Navneet, Sri, Charan. Oh, my gosh. Shri. Pranav, that's not correct, right? Pranav, there will be two breakages, right? Because there are two factors of the denominator,
Yeah,
right?
I just forgot to add it.
No problem at all. We come here to learn, so that's absolutely fine. Yes, Shreya, but there is a way to write it in interval notation, right, Shreya? So on a number line, put it on a number line. Where is minus 4 and 6? So it cannot be equal to these two. So the domain breaks now. How does it break? Minus infinity to minus 4, minus 4 to 6, and 6 to infinity. Minus infinity to minus 4. Minus 4 is not equal, so you put this braces, this parenthesis, okay? Then union minus 4 to 6, 6 to infinity. Any questions, guys? Any questions? Any questions?
No.
No.
Okay. Let me move this. Subi, yes, Subi. That's right. So given an equation, you're able to find the domain, correct? Oh my gosh, the chat window is so big. Okay. So given an equation, you're able to find it, right? Now, let's say I'm going to graph a function. I'm going to show you the graph of a function, and I'm going to ask you to find it. Let me see, okay? Oh my gosh, okay, let's see. And then, okay, let's go ahead and try this one, please. We'll go ahead and try this one. By looking at the graph, you're going to find
Are we finding the domain?
yes, ma. The entire thing is about finding domain.
Are we trying to write the domain, right?
Yes, ma. You get it, guys? Yeah, I got a couple of answers, guys. Nice. Okay, I think we are good with this. Harshika, good. Shreya, good. Shreya, see, you have fallen into the group. Pranav? 1 minute, Pranav. Why Pranav? There's a break. There are 2 breakages, right? Pranav, this is a part of the graph, right? You never
Yeah,
wrote this
I
down.
forgot
Meaning,
about that.
yeah, so it should be C. Minus infinity to minus 2. And then minus 2 to 3. Then 3 to infinity. Make sense?
Okay.
Sahana, good to see the answers from you, ma. Shrikar, that's right. Navni, that's right. You took it as 4. Oh, yeah. See, okay, hold on. 3. Okay, I took it as 4 basically. So 4, 4 to infinity because 3 is a 0. 4 is where the asymptote is. So minus 2 is where the asymptote is. 4 is where the asymptote is. So minus infinity to minus 2, minus 2 to 4, and 4 to infinity. Any questions, guys? Okay.
No.
Now let's move on. Let me check. Mhm. That was easy. How about we'll do end behavior. Okay, end behavior is where your limit comes. Meaning in algebra 2, you were just saying as x tends to minus infinity, this happens. As x tends to plus infinity, this happens. Now you're going to write everything in terms of limit. Okay, so let's go over this. X square minus 4, 3x plus 12. X square minus 4, 3x plus 12. X square minus 4, 3x plus 12. So now we are going to go ahead with end behavior of the rational function. End behavior of rational function means it's all about horizontal asymptote. Now, before I go here, Anya, are you answering, ma? Anya?
Yeah, it answered the question. Yeah, it answered the question.
Yes, ma. Thank you, ma. But that was 4, ma. Minus 2 to 4, 4 to infinity. Do you see the issue there?
Yeah, and no, I just messed up the 3.
No
I saw
worries.
the
As
line
long as
as
you
3
understand.
instead of
Srichar
4.
and same thing. It was 4. 3 was a 0. Did you see that? Akshada, same
Yeah,
thing. In the
that's noticed.
graph, right? 3 was a 0 and the thing was at 4. Ashrita, same for you as well. Okay. So now f of x is equal to x square minus 4 by 3x plus 2. We are just going to discuss the end behavior now. No more domains. Okay. We will revise domains a little later. We have just covered the concept of domains. Now, end behavior is where the limits come into picture. Now that we have covered limits, there's nothing to study new, but we are just going to integrate both. Meaning, whatever we studied in limits and here. So, in algebra 2, what you would have done, 3x plus 2 for the end behavior, right? How do you do? Let's see. Okay. What did you do for applying the limit? Basically, what you need to find, extending to minus infinity, f of x equal to what you need to find? Limit extending to infinity, f of x is what you need to find. Okay. So what do you do here? Who can help me?
Substitute x as negative infinity.
Yeah, that's a good idea. But then here, guys, one thing is, remember the -4 and +2 is not going to carry any value. Okay, when infinity is there for x, right, these are all very minute numbers, you're not even going to bother. Here, x square by x, right, guys? So x square by x is what matters. Other than that, everything is going to be small. X square by x becomes x when you factor it out, right? Now, since it became x, right, you're going to plug in x equal to minus infinity. So when x goes to minus infinity, you're going to plug that value into whatever expression you get. So that is minus infinity. Here it is plus infinity. Any questions? Any questions? Do you all know how to graph this in the TI-84 calculator and find the end behavior? If there is a person who does not know how to put it into the calculator and find the end behavior, you have to ask now. Do you want me to go?
Yeah, I don't know how to put it in the calculator.
X square minus 4, 3x plus 12, right? I'm going to show you. I'll keep showing till everybody is comfortable, okay? TI-84. I know this is a repeat for many, and it's absolutely okay to go middle with the calculator. Those of you who know middle with the calculator and know much more than what you already know, that's what I would say. Okay, so here I go to y equal to, then what do? I go to y equal to, and then what was it, ma'am? Let me see. What was the question I gave you? Do you remember? I remember. X square minus 4, 3x plus 12. X square minus 4 divide by 3x plus 12. Oh, sorry guys. X square minus 4 divide by 3x plus 12. Okay. Okay. This being the case, just press graph. You see? Any questions here? But you're not able to see part of the graph. So what do you do here? Remember, Xmin, Xmax is the minimum maximum on the x-axis. XSCL is the interval, right? Interval on the x-axis. So you didn't see most of the graph, right? So y min, y max, the -10 seems to be very low. So -20, I'll put it as, maybe I'll put it as 10. Oh my gosh, what did I do? Okay, quit. I go here, window, I'll put it as -20. -20. Oh my God, what is that? This minus you need to use, guys, -20. I don't want the XSCL like this, so let me put it out as 2. Y min, I'll put it as -20 here. Okay. Okay. Let's see the graph. Did it resize? Yes, it resized well. But when it resized, the top part is not seen now, right? So I really want more of the plus y axis, more of the plus x axis. So let me put it as 20. Okay, here as well, let me put it out as 20. YSCL can be 2 as well, you see. Now graph. See, is this nice? Now you just need to know the end behavior, right? Is it making sense to write the end behavior on this one? Make sense, guys? See where it is going. When it is here, right? It's going to infinity. It's going to infinity. This is going to minus infinity. This is going to plus infinity. Any questions? Okay. Now that we are on the calculator, right, guys, I really want you all to know a little bit more. So please go to second calc. See 0, you can find it here. Do you see? 0, you can find it here, and value, what does it give you? I think, I don't know what it gives you. Oh, I see. At least I've used the 0. 0, it is enough. Okay, for now, if you know where is the 0, it's easier. See? Left bound, meaning there are many zeros in here, right? So you need to give a left bound and right bound for the 0. That means what it is asking, what is left bound means, think of an imaginary line, left bound, right bound, meaning between those two x values, what is the 0 present is what it is asking. Okay. So now, if I were you, I would not see, I would go ahead and say left bound. Okay. Left bound, that is a left bound, press enter. Right bound, come down, press enter. Yes, guess, and then see 0 is at a -2. Any questions, guys? Okay, so this is how you find the zeros. You should know what is left bound and right bound. Advait, did you follow the left bound and right bound? Annam,
Yes.
did you understand?
Yeah.
Okay, so you know how to put it in the calculator and find, right, ma?
Yeah.
Okay, so I'm going to share my screen again. Sahana, did you get it, ma?
Yeah.
Okay, now let's go ahead and try this one. I really want you to try this one. Okay, how about this? You can use a calculator, guys. I just need the end behavior of this rational function. The thing is, now you're given a graph, you'll know. You're given an equation, you'll know to find the limits. Limit is applied only for the end behavior. End behavior depends on the horizontal asymptote. Now, the one thing that's pending is if you're given a table, what do you do? How do you fill in these values? Can you try and tell me? I can share with you, do it and show you as well. But I would really like you to try. How do you type this? Meaning you go to the function wherever y equal to and type this function. That's easy. But how will you fill in this table? If they ask you to fill in this table, that's when you tell me how do you fill in that table. You tell me, guys. Harshika, do you know how to fill in that table, ma?
I think you have to plug in the x values into the equation
Yeah.
and
Do you
then
know how to do that? With what
yeah,
keys in the calculator, ma?
yeah, I think so.
Okay. There is a table set, right, guys? Blue table set. Please use. First you type in y equal to, because see, using calculator is a skill.
Priyanti, I got to the table setup mode, but I don't know how to make it do it. You're on mute. Oh.
No, I'm going to go back and share this. You have the question with
It's
you, ma?
it's on auto ask,
Yes, auto ask, right? So when you
Yeah.
do that, independent value is it cannot
Ask.
meaning no, or independent value is ask, yes. Dependent value is auto. You need to set like that. Then only you will be able to input your x value which is there in the table. Make sense?
Yeah, but now I don't know how to make it go to the table.
Don't know how to go to the table. This one? Second
Oh,
table.
okay.
Wait, just to confirm, the denominator was x squared minus 2x minus 24, right?
I'm sorry, ma. I'll bring it up. X square minus 2x minus 24.
Okay.
Make sense? Ah. Okay, if you're going to take care, I can share that rather than this. I cannot share both. That's what I'm saying. I can share.
Yeah, I got it now.
You got it?
Mhm.
Okay, everybody
Yeah.
got it? Then I can move on to the board. Mhm. Done, guys? Okay, can I get the value? Okay, let me ask. What did you get, Navneet, for this one?
I'm doing it.
Wait, which value do you want us to send?
So you can give me any one value, Ashita.
Okay.
As long as you get it one value right, you should be fine. Let's find 10 and minus 10. Let's find 10 and minus 10. Pranav, are you able to type it in the calculator and find it?
Yeah, I can.
Mhm.
So you want us to send minus 10 and 10?
10 and minus 10. That's right. Good job. Pranav, can you give me the decimal values, Pranav?
Can you?
I don't know how you're doing the fraction. Are you directly substituting?
No, it's like it's giving me the fraction online.
Oh, in your calculator?
I'm doing it on the website.
Website, okay. Okay. Sricharan, that doesn't seem right, Sricharan. You want to share screen?
Arajira. Oh, I see.
What is minus 43.61?
That's the 10.
Hmm?
That's 10. Or I1x is 10.
That doesn't seem right. Do you want to share the screen? Did you put 4x minus 1 by x square minus 2x minus 24?
I got the same thing.
What do you say the question was?
4x
Four.
minus 1 by x square minus 2x minus 24.
Yes.
Can you please share the screen, one of you? I'm glad you're bringing up these. Can you please share the screen? Akshada, that's right, ma.
I'm sorry.
So please, guys, those of you who did it, right, it's important that you find out the error. Okay, I'm not going to tell what is error. I know what is error already.
Oh,
Okay,
Then
what
put
is error?
parentheses.
Ah, exactly. That is so much difference. Good job, guys. I'm glad. Hey, how do you insert it? You have to teach me, Sri Charan.
I don't really do anything. Oh,
Insert, you just scroll over what you want to do and you just type in.
yeah, I don't
Oh,
like
then
it though.
it'll insert. Huh? Oh, okay.
Yeah, it will like
Every time I delete and do. Okay.
you have to like, or you can do second delete and there's an insert button which will just insert it in.
Oh, second delete. Huh? Oh, I see. I see. Oh, second delete is insert. Oh, thank you. Mr. Charan, again you're forgetting the parenthesis. Anam, did you get the answer?
So for 10, is it 10 comma 0.6964?
Really? Correct.
Okay.
Shri.
He's right.
Anya, did you get the answer, ma? You're not answering, right? Harshika.
Yeah, I was sending it.
Annam, you got the same thing, 0.696 for 10 and
Yeah.
minus 0.427. Okay, so the
Yeah.
parenthesis makes a big difference. Okay, can I share my screen, Sri Charan? Yes. Okay, so that's good. That's a learning. Now, please write the end behavior for this. Please write out the end behavior based on the table. Based on the table, would you be able to write the end behavior? Check. Otherwise, please don't switch off videos, ma. You know what? I'm going to run out of battery. Vinesh, ma. Done. Anam, did you get it?
So as x goes to negative infinity, y goes to negative infinity, and then as
Is
x
that so?
goes
Why
to
is that so? Okay, you want the table? Let me go ahead and show you what the table values are. I got these as my table values. Did you get this, Annam? You got this,
wait.
right? If it was algebra 2, how would you write your end behavior? You see this, you see the table, okay?
Yeah, this
As
is what I
x
got.
goes to minus infinity. This is minus infinity, right? This is a very
Yeah.
small number. Minus 4 divided by 1, 2, 3, 4 is a very small number. Y goes to 0. This is what you would have written. As x goes to plus infinity, see, y again goes to 0. This is what you would have written if you were in algebra 2. But here you have to introduce limits. We have already learned limits too much. Okay. So limit x tends to minus infinity, f of x will be equal to 0. Limit x tending to plus infinity, f of x equal to 0. That is your end behavior. Can I move on? Subi, did you get it? Anya would love to see your answer for every question. Sahana, did you
I
follow?
did. I
Ma'am?
submitted it.
Okay. Did you follow?
Yeah,
Wait,
I put my answer in the chat.
Yeah, ma. Okay. I did not see
Priyanti,
the last two. Yes, ma.
this might be a dumb question,
No
but
problem at all.
why isn't it y going to negative infinity?
Oh, what? Okay. Okay. Explain to me, why do you think y is going to negative infinity?
Because the more smaller the x value gets, oh, y is also getting but
Okay. Amma, see
yeah,
here. What is this value?
4 over
Minus
uh
4 over
minus 4
1, 2,
over
3, 4, right?
mm-hmm.
So what is this basically? Is it going to be a big number or a small number? Think about that.
Really small number.
Really small number, really small negative number, correct?
Yeah.
There is this really small negative number on the y-axis. Here or here?
Yeah.
Here, right? This is your end behavior, right?
Yeah.
That's why I said y tends to 0.
Oh, okay. Okay.
You got it?
Okay,
You have to
yeah,
deeply,
yeah,
I
I get it.
understand why the confusion is coming, but this is a very small value. Small values are around this region. You see?
Uh-huh.
On the y-axis. It's only if it goes there, it's plus or minus infinity. Got it?
Yeah, got it.
So try to put it out and clearly think, hey, is this a small value or a big value? Now, coming to the horizontal asymptote, right? I really want you to understand this one. The line y equal to b is a horizontal asymptote of the graph of f when limit extending to minus infinity f of x equal to b, or if limit extending to infinity f of x equal to b. In both sides, on both sides of the x-axis, when x is moving to minus infinity or plus infinity, if your graph value tries to go ahead and join the line that is y equal to 1, y equal to 2, y equal to 3, those lines, if it tries to join, what they are saying is, here, suppose if there is a graph, let's say this is 1, 2, 3, minus 1, minus 2, minus 3. So now, suppose if you have a graph like this, right? Here clearly, what is this? This graph on this side, when x tends to limit extending to infinity, f of x is tending to a minus 1. It is trying to go ahead and attach this with this line y equal to minus 1. So that is your horizontal asymptote, is what they are saying here. Okay, I'll move on. Okay. Now, sometimes graphs cross the horizontal asymptote, sometimes they don't. Okay, there are very special scenarios where the graph, the rational function graph will cross your horizontal asymptote. We'll do one problem on that. Okay, now coming to end behavior, right? Meaning, which we are discussing right now, right? Suppose your question is, suppose they give you this function. I'm going to erase everything. Okay, we are going to discuss more horizontal asymptotes only. F of x equal to 2x plus 3 divided by x square minus 4x minus 32. If you're given this, right, how do you do this? How do you do this? See, when your input is, we are going to try the end behavior. What is the end behavior? Basically, limit extending to minus infinity f of x, limit extending to plus infinity f of x, correct? Now the thing is, limit extending to minus infinity f of x is there, limit extending to plus infinity f of x is there. Here, see, your input is going to be a very big number, very big negative number, very big positive number. So take that into account. These things don't carry any value in front of them, right? So what carries value? So basically, what should I do? Here, you can clearly say the polynomial in the denominator dominates the polynomial in the numerator. What does it mean? What does it mean to say the polynomial in the denominator dominates? Okay, let me show you. So here, these all don't carry value at all. Okay, 2 is not in, let's say my input is a very big value. Infinity means it's a very big value. Let's say 1 followed by 6 zeros. Okay, now 1 followed by 6 zeros, 1 million square minus 4 times 1 million. Think about it, guys. So here, what happens? which one you should consider more? Can I take away this? Meaning, in front of such a big number, we don't even need to worry about this, right? What happens here? This becomes such a huge number. This is even small number. So can I say 1 by like infinity? This is like an infinity number, right? So if that is the case, what is 1 by infinity? 1 by a very, very big number is what? Is almost equal to
0.
0. Make sense, guys? So basically, when the degree of the denominator is higher than the degree of the numerator, the denominator polynomial dominates the numerator polynomial. And because of that x square, we always tend to write end behavior based on high input values. Positive or negative, it's going to be a very big number, right? So in this case, here it will become 1 by infinity equal to 0. Any questions, guys? Any questions on that? Okay. Now, both ways it will happen. It will be 1 by minus infinity will again be almost 0. But again, this will be a negative very small number. This will be a positive very small number. We are approximating it to 0. Okay. So let's try this one. You're going to tell me this one. You're going to try the end behavior for this one. Okay. 2x plus 3 divided by x square minus 4x minus 32. Quick ma. The other easiest way of doing this is divide numerator and denominator by x square and substitute infinity. Divide numerator and denominator by the highest possible power of x. In numerator, and x square is the highest possible power, right? So divide both numerator and denominator by x square. That's another quick way of doing. We have also discussed this basically. 2x by x square plus 3 by x square divided by x square by x square minus 4x by x square minus 32 by x square. See what's happening here. So when you limit extending to infinity means what happens? Extends to, let's say plus infinity first. You see here what happens, this becomes x, this becomes x square. So 2 by x plus 3 by x square divided by 1 minus 4x, 4 by x, right? And then minus 32 by x square. So when you put infinity, right, what happens? This becomes 0, this becomes 0. So the numerator becomes 0. Here 1 minus, if you put infinity, right, 4 by an infinite number is what? 0. 32 divided by infinite is what? 0. So 0 by 1 will be 0. Any questions, guys? Advait, did you get it?
Yes. Yes.
How about Annam? Mahir, how about you, Ma? Mahir, are you following? Okay. Okay. How about this, guys? You're going to try this one, okay? Both. I'm just going to give the problems to you. You're going to do. G of x will be equal to x cube minus 3x plus 5 divided by 5x square plus x plus 12. That is question number 1. Question number 2, you're going to do h of t will be equal to 2t plus 3 by t. You're going to find out the end behavior. This is the second part. First part we discussed domain. Second part we are discussing the end behavior. My charger is going to go. It's only 2%. Okay. Do you get that? Both. You can send both to me. Okay. After that, I really want to move on to what? Yeah, I want to revise the horizontal asymptotes that we learned in Algebra 2 and do 2 problems. See, because we learned limits, this unit will run.
Do you say the domain or the asymptote?
My end behavior. See, there is a heading simple small EB I have written end behavior. Done, guys. Can I move on? It is my chat window. Yep, I got several answers. 2 to infinity. 2 to infinity. Is that right? 2, really? Oh, wow. Nice, Shrikar. Anya, is that right, ma? Have you already given the answer, Anya?
No, I'm typing it in the chat.
Okay, okay, ma, okay. 2 to... Ma, okay. It tends to infinity, yeah, correct. Akshada, correct. Sri Charan, correct, Sri Charan. Navneet, I'm waiting for your answer, right, Navneet? Pranav, have you already sent the answer?
Sent the first one.
I think so, correct. Ashita, both are right now. Subi, both are right.
Okay, I sent.
Anya, correct, ma. Minus infinity. First one is minus infinity. Yeah. So basically, yeah. Annamadvait, I didn't get yours. Shriya, where are we? Is it too hard? You got it?
Yeah, I just
Oh, yeah. Sorry. You are the last one. I'm just saying. Yeah. Yeah, you got it. So you are riding the wave now. Good. Second one, you got it? Okay. And you all remember, this is from algebra 2. Okay. So you know how to add the limits to our end behavior now, right? So let's go ahead and do this one. Remember, for the horizontal asymptote, there were 3 things that we were discussing. Let me put down, let me copy that rule we learned in algebra 2. I don't want to redo what we learned, but remember this, guys. I don't know if you remember. Do you remember these? Do you remember these? Should we go over this?
Yeah, I would like to go over this.
Okay, sure. How about this? You remember this? That's so hard. When you look at it, it's so hard. First of all, how do you find the horizontal asymptote? Suppose if you have this function like this, a function like this. Here, the degree of the denominator dominates the degree of the numerator, right? So degree of the denominator is bigger. So what happens if the degree of the denominator is bigger? What was the rule? Do you all remember? Degree of the denominator is bigger means the horizontal asymptote was y equal to 0, right? Then degree of the numerator is bigger than the degree of the denominator. Degree of the numerator is bigger. Here y equal to 0 is the asymptote. When the degree of the numerator is bigger, it is divisible. Do you see? You can do long division, x square minus 4 divided by x. As a result, there will be a slant asymptote. So there is no horizontal asymptote. Okay, the degrees are the same, x square minus 4 divided by x square minus 3x plus 2. If you're given that, then the horizontal asymptote is equal to the coefficient of the highest term of the numerator divided by the coefficient of the highest term in the denominator, right? So y equal to 1 is your horizontal asymptote. Are you all with me? This is just a revision of algebra 2. Are you all with me? Can I move on? Mahir? Can I move on? Okay. Now, see, that's the same thing given in the next one. But you know what? We should get confused, right? We are learning algebra 2 and we should get confused. So it's all given big. Basically, what are they saying, you know? This is a rational function they are saying. What does it mean? Polynomial by a polynomial, okay? Numerator by denominator polynomial. How the numerator polynomial is written? An x power of n. See, an means the nth coefficient plus an minus 1 x power of n minus 1. It keeps on going till a0 x power of 0. X power of 0 is 1, right? Anything power 0 is 1, so it ends with a power of 0. Similarly, in the denominator, they start with bm x power of n. They do b of m minus 1 x power of n minus 1. Like that, it moves on till b0. b0, x power of 0 will come. X power of 0 is 1, so they just end with b0. Any questions? So what are they saying is this is basically a polynomial, this is basically a polynomial. Polynomial by polynomial becomes a rational function. In a rational function, how to do? What is n? N is a degree of the numerator. M is the degree of the denominator. Makes sense? So let me write it out as m here. Okay. So degree, highest degree of the numerator, highest degree of the denominator, m and n. Okay. Numerator greater than the denominator means I'm sorry, numerator less than, right? Meaning x by x square comes, then y equal to 0 is our horizontal asymptote. It's the other way means you cannot have a horizontal asymptote. Both are equal means you have to go with the coefficient am by bm. Any questions? This is bm as the horizontal asymptote. Are we clear? It's not a big thing. To write the polynomial is very easy. Remember, it starts with an. N is the numerator power, right? So x power of n is your highest power and it goes till, meaning just to subtract 1, subtract 1, subtract 2, subtract 2, like that you keep on till a0. Denominator is b of bn, bm, right? Power of the numerator, denominator is m, so bm x power of m. That's your start. And then you keep on moving with m minus 1 x power of m minus 1 till b0. Okay. And next week, guys, if you all have time, right, just Google out what is Pascal's triangle and come back. Okay. For next week, I really want you guys to Google out what is Pascal's triangle. Okay. It's something amazing. If you have some initial knowledge, it's so nice to know Pascal's triangle when we work on binomial theorem. Before I forget, I told you that. Okay. Now I'm going to give you just 3 problems. You can just tell me. You don't need to work out anything. Okay. You're just going to tell the answers. X cube plus 3x square minus 1. Advait, you want to say what is the horizontal asymptote here? If you don't know, it's okay, Advait, but I'm not putting you under the bus. I'm just asking you know. If you don't know, I'll ask somebody else to answer.
Um,
You want to try, try. You can pass it on too. Pranav, you can help us, or Shriya, you can help us.
Brandy, can I try?
Yeah, go ahead. If there's a volunteer, I would be happy. Go ahead.
So, since the degree of the denominator is bigger,
Is
then
bigger,
y
yes.
is equal to 0.
0. Good job, Ma. How about this? X square plus 2x minus 15 by 4x minus 3. Please, guys, I really want whoever doesn't know to try. Who is doubting it, please try. If you know, you can just keep quiet. You want to try again, Ma? Okay, go ahead.
Yeah. So since the degree is bigger on the numerator, so it's no asymptote.
No asymptote. Good. The last
Okay.
one is, yes, the last one is x square plus 5x minus 36 divided by 3x square plus 21x. Can Sahana try? Or I'm putting you as well under the bus. If you feel so, then I'll switch. You don't want, I respect it, you know. It's okay. You don't want to?
Yeah.
Yeah, you don't want to double think. Okay. Anya, you go ahead, ma. Anya, go ahead. Anya,
Fine. Yeah.
do you want to say the horizontal asymptote? Are you in this class? You want to say
Yeah,
the
wait,
horizontal?
I'm almost done solving. I need a little bit of help.
Yeah, I will go over. No problem. Okay, Ashita, do you want to help us?
Try. Can I do it?
Yeah, try, please, Pranav. Thank
Is-
you for volunteering. Sorry, Ashita. Wait, ma.
Is it 1/3? Is it
1/3. Good job. Because the degree of the numerator and denominator is one and the same, so it is 1/3. Y equal to 1 by 3 line is your horizontal asymptote. How will the 1 by 3, y equal to 1 by 3 is somewhere here, right? So basically, I don't know how I honestly don't know how the graph is going to turn out. For some reason, it's going to come and go here. And this graph may be going here, something like that. That's where, see, both the graphs are trying to merge with y equal to 1 by 3 line. It will be like that, I think. Okay. Okay. Now, how about this? G of x equal to x power of 4 plus 3x square minus 5 by 4x power of 5 minus x cube plus 2x. Here, can you apply, meaning, you know what, I want to evaluate the following limit. Wait. Evaluate this we studied for the last 3 weeks, I'm thinking, okay. Can you evaluate this limit in the rational function? Evaluate this limit on the rational function. Each of you can answer in chat. You can answer in chat, okay. I'll give you 2 questions on evaluating limit on rational functions, because what are we doing by evaluating this limit at minus infinity? We are trying to determine the end behavior. That is why this is given as a separate task. 2x minus 5 divided by x square minus 9. Can we evaluate the limits? Both the limits. You can send the answers, please. So just send the answer alone, guys. It's just two answers, direct answers. I just gave you one. X power of 4 I gave you. Nice. X plus 4, x plus 5. Where is that? What did I give you? X plus 4. Oh yeah. Nice. Shrikar, nice. Advait, okay. Advait, very nice, Advait. But why is that you're doubting between those two values? Can you explain?
I got 2 different answers and I just wanted to get my answer in before you moved on.
Yeah, very nice. Thanks. Really nice. Why did you get a 4? Meaning, just explain to me how are you getting a 4? We'll clarify that. Meaning, it's useful for everybody. How did you get 2 answers?
No, I accidentally just multiplied it by 2 again. The answer. Because in the power, I accidentally just did 2 power 2.
Okay, let's do this. Okay, let's do this. Okay, here, you're going to substitute x equal to infinity, right? This is going to be 2x square. Maximum is going to be 2x square, correct? Correct? The max power of x is going to be 2x square. Rest of
Yeah.
it, this is x when you multiply. This is as well x. This is a constant. So I'll just take 2x square by x squared, right? Now, you see here, the both the powers of the numerator and denominator are one and the same. So you'll go with the coefficients, right? When x is tending to infinity means right side, right? So basically, you'll go with the horizontal asymptote would be the coefficient of the highest power of x in the numerator divided by the coefficient of the highest power of x in the denominator, right? So your horizontal asymptote will be y equal to 2, correct, ma? So this limit will tend to be equal to 2. Make sense?
Yeah.
I'm
I
just
think,
wondering, where did you get the 4? I can help you if you can tell me.
the problem,
Shout out, Advait.
because it was
Anything?
2x squared plus 3x minus 20.
Okay, okay.
divided
Oh,
by
you
x
did that.
squared.
Okay, okay. I'll do that. I'll do that. Wait, somewhere I'm not understanding where you got. 2x square plus 8x minus 5x minus 20 divided by x square minus 9. Then what did you do?
I
2x
plugged in a
square
whole
minus 9.
number. I plugged in x equals 3 instead.
You plugged in x equal to 3, huh?
Yeah.
Why?
So it gave me 4. I just made a mistake.
Huh?
It was just like I just made a mistake in the
Yeah. See, you
calculation.
cannot plug in x equal to 3, right? Because if x equal to 3, your denominator will become 0, right? X equal to 3 is an asymptote. Do you see x plus 3, x minus 3 will come in the denominator. So that will become an asymptote. You cannot plug in x equal to 3 at all, right?
Yeah.
Make sense? So the
Yeah.
thing is, what you can do, this big thing you will have to simplify, right? Divide by x square everywhere. Divide by the highest power of x everywhere. X square, divide by x square, divide by x square. If you do that, you end up having 2 by x minus 13 by x minus 20 by x square. Divide by 1 minus 9 by x square. Now you substitute x is infinity. Infinity means big number. If a denominator constitutes a big number, this adds up to 0, 0, right?
Yeah.
Sorry, 2 by x square, right? This is 2. Okay. 2 minus 0 you get. So your numerator turns out to be a nice 2. In the denominator, you have 1 minus 9 by x square. 9 by x square is 0. So the denominator will become 1. That is why when x is going to infinity, your graph value goes to 2. Does it make sense?
Yeah.
A shortcut way of doing it is everywhere you divide by the highest power of x. If you have a rational function, you'll get it correctly. Make sense?
Yeah.
Okay. Shall we stop here, guys? I hope you got. What did we finish today? Let me check once. We did 1.7a, 7b. Nice. 1.7a and 7b we did. Had we not done limits, we would have taken this longer. Okay. Next week I want to do 1.8. I don't know how many we have. Okay. The quicker we finish unit 1, we can move on to exponential and logarithmic function, which is unit 2. Okay. So I will try to finish unit 1 and give you a test. Then go to unit 2, which is exponential and logarithmic functions. Once we finish that, your AP pre-calc test is going to test you on only 3 units. Only 3 units will be asked for AP pre-calc exam. Okay. Of that, we will be completing 1 unit next week or maximum the next week. The second unit is on exponential and logarithmic function. It is also an extension of algebra 2. However, there will be extras now that we have learnt limits. So that is done. So 2 pieces of 3 is done. The third unit is entirely new to you all. Third unit, you cannot afford to miss classes. That is on polar graphs and trigonometry. That is a little complicated. So I prefer you all coming to proper classes for the unit 3. Having said this, the fourth unit is there, but most of the schools don't do it. It is taught, but it is not asked for the AP pre-calc exam. Am I clear? Which is on vectors parametrics, which is a good one. We'll try to do whatever we can, but only 3 units are there for the AP pre-calc exam. Okay, for 2027, they have changed some pattern a little bit. Okay, number of minutes have been modified. That's okay. Okay, any questions for me? Okay, yeah, we'll stop here. I'll just do 1.7a, 7b for this week as homework. If you have any questions, please come back and ask. Okay, and everybody wanted the class to be at 6, right? Do you want the class to be from 6 to 7:15? How many of you can do? Please
do.
tell the answer and log off.
I can do
Okay,
that.
Shrikar says yes. Others?
Yes.
Yes.
If there is there a no?
Um,
Advait, particularly, yeah, Annam and Advait.
yeah, I think 6 to 7:15 is fine.
Okay,
I think it works. It'd just be tight, but I think we'll be fine.
it'll be tight, for you.
Yeah, but it should be fine.
Okay, 6 to 7:15 from next week. Just because of you guys asking only, because you're all from school and I want you to refresh a little bit. I don't mind. Okay, okay, guys. See you all next week, ma. Bye-bye.
Bye, Miss Priya.
Bye.
Miss
Bye.
Priya.
Hey,
Bye.
Ashrita. Bye, ma.
Yeah.
I just had a question on that math circle.
Okay.
Did you get the details?
Yeah, they sent me an email. They sent us the link for like the Zoom meetings. They start from September.
Did you
And
register?
yeah.
Okay. Did you register? Did you register for in the Zoom